Hello everybody, we're getting ready to do lesson 12.2 part 1, grade 6 math today. And 12.2 part 1, independent and dependent variables and tables and graphs. You got 42 points on your classwork sheet here. And then 9 points will go into your notebook or your notebook guide, have that out. Name, date, period, students, and then due date for onliners and homeschoolers. And let's go into today's bell work. Write the rule for each table. Write a rule for this table, students. And then down here, write a rule for this table down here. Teachers, give your students about 4 minutes for this. See you in 4. Okay, welcome back everybody for today's solutions. For today's bell work, write the rule for each table. X and Y, X 1, 2, 3, and 4. Y is 5, 10, 15, and 20. So for this table up here, we have increments here, or changes of 1 for X, and then for Y we have increments here of 5. So it increases by 5 each time. So Y would be 5 times X. So we have 5 times 1, 5 times 2, 5 times 3, 5 times 4. So Y equals 5 times X. And then down here, 0, 4, 8, and 12, we add 4 each time to our X. And then for our Y, we add by 2 for each movement of X here. So each part of the table here on X, we move up 2. So for this one here, Y would be 1/2 of X. So Y it would be 1/2. 1/2 of 0 is 0. 1/2 of 4 is 2. 1/2 of 8 is 4. Then 1/2 of 12 would be 6. So Y is 1/2 X. Okay, essential question here. Explore activity. Identifying independent and dependent quantities from a table is our lesson for today. Identifying independent and dependent quantities from a table. This goes in your notebook. And let's go into our page 2. Again, into your notebook. Many real-world situations involve two variable quantities in which one quantity depends on the other. The quantity that depends on the other quantity is called a dependent variable, and the quantity it depends on is called the independent variable. So we got some good vocabulary here, students. Put this in your notebook. Okay, moving on now to our next problem here. A freight train moves at a constant speed. The distance y in miles that the train has traveled after X hours is shown in the table. So here's our time up here: 1 hour, 2 hours, 3 hours, and then our distance: 0, 50 miles, 100 miles, 150 miles. What are the two quantities in this situation? So what two quantities are described in this table? So which of these quantities depends on the other would be the second question. So our first question is, what are the two quantities? The second question is, which of these quantities depends on the other? So what two quantities are time and distance? Those are our two quantities. And then which of these quantities depends on the other? Distance depends on time, right? I mean, you go 0, at 0 time you go 0 miles. At 1 hour, how many miles you go? 50, etc. So distance depends on time. What is the independent variable would be the question. And what is the dependent variable is the next question. So think about that. And then B, how far does the train travel each hour would be a question. And then the relationship between the distance traveled by the train and the time in hours can be represented by an equation in two variables. So we can represent this table here by an equation. So up here, what is the independent variable? Would be x. Time is independent of distance. Time's going to happen anyways. Distance depends on time. So x and y. X is your independent variable. Y is your dependent variable. Distance is dependent on time. And then B, how far does the train travel each hour? 50 miles here. 1 hour is 50 miles. So this is the way that you can determine or how to write an equation in two variables from a table. So distance traveled in miles equals distance traveled per hour times time in hours. So that would be how you determine distance. Be distance traveled per hour times time. So in this situation here, y, y here is our dependent variable. Y equals distance traveled per hour, which is 50 miles, times time, which is x. So here y equals 50x. It would describe this table here. So an explore activity for this, a reflection here. Analyze relationships. Describe how the value of the independent variable is related to the value of the dependent variable. Is the relationship additive or multiplicative? Would be a question. And then question 2, what are the units of the independent variable and the dependent variable? So what units are we talking about here? And then 3, a rate is used in the equation. What is the rate? So describe the rate down here, students. Teachers, give your students about 2 or 3 minutes to answer these questions. And then back up here, describe how the value of the independent variable is related to the value of the dependent variable. Is the relationship additive or multiplicative? The value of y is always 50 times the value of x, so it would be multiplicative. Then number 2, what are the units of the independent variable and the dependent variable? Independent variable is hours, and then the dependent variable would be miles. And then number 3, a rate is used in the equation. What is the rate? It's 50 miles per hour. Here's your rate here. 50 miles per hour. This would be like for a fraction bar here to per. So explore activity 2. Identifying independent and dependent variables from a graph. In explore activity 1, you use a table to represent a relationship between an independent variable, which is time, and a dependent variable, distance. You can also use a graph to this relationship. So a graph, to graph this relationship, an art teacher has 20 pounds of clay, but wants to buy more clay for her class. The amount of clay X purchased by the teacher and the amount of clay Y available for the class are shown on the graph. So here's our graph here. So on your y-axis will be the clay available for classes. That'd be your y-axis. Your x-axis will be clay bought by teacher. And then this would be the graph here. So our teacher has 20 pounds of clay but wants to buy more. The amount of clay X purchased, so X here, clay bought X. And the amount of clay available for the class are shown. So clay bought and then clay available. She starts out with 20 pounds, and then see the clay bought by teacher would be 20 pounds here. So for every 10 pounds, 20 pounds, 30 pounds, that'd be one way you could interpret that. And then clay used by the class. So she starts out with 20 pounds. Then the clay available for class, and then clay used by the class. If a teacher buys 10 more pounds of clay, how many pounds of clay, how many pounds will be available for the art class would be the question. So if she starts here with 10 pounds, it'll be 30 pounds would be the amount here. So clay available will be 30 pounds. So she buys, she had 20, she bought 10, so now she has 30 pounds available. If the art class has a total of 50 pounds of clay available, 50 pounds of clay, which would be up here, how many pounds of clay did the teacher buy? So she has 50 pounds. Down here is what she bought. So she must have bought 30 pounds, right, for that? So right here, must have bought. How can you use the graph to find this information? So again, here's our graph again. She has available 50 pounds of clay. So how many pounds of clay did she buy? And then your arrows down here. This amount, this part on your y-axis corresponds to this x coordinate here. So when she has 50 pounds of clay available, 30 pounds, find a point on a graph within a y-coordinate of 50. So here's 50, and this corresponds down here to 30. Then find the x-coordinate at this point, which is 30. So at 50 pounds, according to this graph here, at 50 pounds, she bought 30 pounds of clay. And that is 12.2 Part 1, Grade 6 Math. Animated PowerPoint Math Video, AOL.com for questions or course materials. Thank you very much.